Good morning, Year 11, and welcome to the first of today's two videos on our topic on waves for our double lesson today. So the first of these is going to look at wave equations. Okay, so I'm going to go through a few bits and pieces on the slides, then I'm going to do a walkthrough of a worksheet that I will attach into Go for Schools for you to have a go at. Okay, let's make a start. So, first of all, some do now questions for you. So I'd like you to have a go at these in your book. Pause the video now, and then we will move on. Okay, how did you get on? So, the first of those, these are the answers you should have got. The first one was a longitudinal wave, then the second one was a transverse wave. Third question asked you about the difference between potable and pure water. You can see the answer there. Fourth question talked about red blood cells. And then the fifth question was asking you about oxygen and hydrogen bonding. And you can see the answer there. Okay, let's move on. So, we've introduced the idea of waves from yesterday's lesson, or Wednesday's lesson. Sorry. What I'd like you to do, talk about now is some of the features that waves tell us. Okay, so there are 4 bits of information that we need to be aware of. So I'd like you to copy these down. The first is wave frequency, given by the letter F, and this is the number of waves that pass a particular point every second. It's measured in something called Hertz, Hz, as you can see there. The number of waves that pass a point every second. The second of these is something called the time period. And this is how long it takes for one wave, one oscillation, to pass that certain point. Okay. Now we'll talk about time period in a bit more detail in the next part of this double lesson. But for now, please just write down the feature. The third is wave speed. So this is how fast an actual single wave is travelling. It's measured in meters per second because it is a speed, it's velocity essentially. And then the final one that we're interested in is wavelength. It's given by this, what looks like an upside down Y. It's called a lambda. And this is the actual length of a single wave in meters. Okay. So the wave frequency, the wave speed, and the wavelength are the ones we're going to focus on today. So we're going to look at the wave equation. The wave equation tells us that wave speed equals the frequency times the wavelength, or V equals x times lambda. And in the units that we have already written down, that should be meters per second equals hertz times meters. Please can you write down the wave equation into your books. Okay, so we're going to do a worked example first of all. Okay, and let's look at this example and we'll see what we get. I'm going to talk through this with you. Okay, so it says that the air horn produces a sound wave. Produces sound waves at a constant frequency of 420 hertz. Okay. Then it tells us that the wavelength of the sound waves is 0.8 meters. Calculate the speed of the sound waves. And it says to use the correct equation from the physics equation sheet. Now, obviously, we've just been talking about the wave equation, so we don't need to worry about that too much. But what I'm going to do is I'm going to talk you through this calculation. So, sorry, just bear with with me 1 second while I get set up. So here is our wave speed calculation, our wave speed equation. As we know, it is equals frequency times wavelength. For the one with the question we've just been asked about, it had a frequency of 420 Hertz and a wavelength of 0.8 meters. It's important to remember that this always has to be in meters, so you may have to convert, and that frequency always has to be in Hertz, and so you may have to convert that as well. Okay? So, all we need to do therefore in our calculation is 420 times 0.8 gives us 336 meters per second. Okay, there's our answer. So our answer for the speed of the sound waves is 336 meters per second. Okay. Now, a little back up a minute, because we're going to talk about standard form briefly. So when you have to deal with big numbers, we use standard form, and you'll be familiar with standard form from maths, and we've used it previously as well. So the number 13 million, for example, would be shown as 1.3 times 10 to the 7, because we have 1, 2, 3, 4, 5, 6, 7 places to move the decimal place. And you need to know how to enter that on your calculator. So I want you to have a go at practicing how to write in standard form on your calculator. Okay? Get used to using it. The other thing you need to be able to do, as I mentioned, is converting units. So wave speed will always be different in meters per second. However, wavelength could be in kilometers, millimeters, centimeters, but it has to be in meters in order for the maths to work. Frequency could be given in kilohertz, but again, it has to be in hertz. So, for example, 10 kilohertz is 10,000 hertz. 1 kilohertz is 1,000 hertz. So before we go on, I'd like you to have a go at converting the following into the correct unit, either meters or hertz. Okay, so then choose 3 of those to try and write in standard form. So pause the video now and have a go at those 6 numbers that you can see on the screen. Okay, how did you get on? Hopefully you worked those out okay. What I'm going to do now is guide you through a worksheet. Okay. If you have had any questions so far, I will be online during the lesson time on Friday for you to have a chat through and anything. Okay. What I'm going to do is I'm going to guide you through the worksheet of worked examples that we are using for the rest of this lesson. So this is the worksheet you've been given. Now, you don't have to print this out. You can just write out this first part, the top boxes, into your book like this and fill in the information, and then the questions below you can just answer. But the reason I've done this is this will guide you through how to work out different parts of the wave speed equation. So the first column is calculating wave speed, the second column is calculating frequency, the third column is calculating wave length. And we're going to do it in a 4-step process. L, E, S and S. Okay, so here's our worked example. A sound of wavelength 16.5 centimeters has a frequency of 2000 Hertz. What is the wave speed? So So it says first of all to list the values that we know and any conversions. Okay, now just as a reminder, I'm going to write up here the wave equation so that I can remember and refer back to it. Okay, so here I've been given, okay, wavelength. Now wavelength, remember, is in meters. I'm going to use the lambda for that, sorry. And it's in 16.5 centimeters. Now remember, we need to convert that. Okay, now from your conversion, you should remember that to get from centimeters into meters, we need to divide by 100. So 16.5 gives me an answer of 0.165 meters. We've also been given a frequency of 2000 hertz. We don't need to do any conversion for that. What we don't know is the speed. Okay? So what's our equation? Well, we're working out wave speed. So we're going to do V equals F times lambda. We're then going to substitute the values into the equation. And then we're going to state the final answer. So let's do our equation here. Oops, sorry, stay on button. And you'll notice we've got an answer of 330, and because it's wave speed, it's in meters per second. Okay? So that's my first one. So what I'd like you to do, okay, is have a go at the others on in your table. Okay? Now, working through the same process. This time, you're trying to find out frequency. You're given the answer for lambda, okay, which is 5. You're given the wave's speed of 500, and you're not given F. I'm not going to go any further on that. Oh, other than to say, what is the equation that we need? This is the equation, but we need to try and rearrange the equation to find out frequency. Okay, and then the final question is about light travelling at 3 times 10 to the 8 meters per second and has a frequency of 4.5 times 10 to the 14. What is its wavelength? So this time we don't know wavelength, we do know frequency. So we're going to have to rearrange our equation again. And we can hopefully work it out from there. So I'd like you to have a go at that. Secondly, I'd like you to work through the practice questions on the sheet as best you can. And then I'd like you to try and fill in as much of the box here as you can at the top of the sheet. Okay? And if you're able to, see if you can get onto the extension task. Once you've done that, please try and submit that work into Teams, okay, for me to look at, and then there will be a second video for you to have a look at for the second part of today's lesson, which will be a little bit shorter. Okay, good luck with that. If you have any questions, please do let me know.